Good morning. Good morning all. I would like to welcome you to our webinar. My name is Bart Overgouw, and as a business unit manager, I am responsible for the unit logistics within ICT Group. I'm accompanied here by Karsten Pereboom and Pieter van het Hof. Karsten is one of our business consultants, and he will give the presentation. Pieter is one of our architects who has worked on some of the projects that we present during this webinar. I'm glad that you take some time to hear what our vision is on what we call the Container Terminal Unified Platform and how we think that this is the key to become part of the smart terminal. In this presentation, we will use the term port terminal for short or terminal. But first, let me show you the agenda of this webinar. You can ask your questions in the chat, so feel free to do that. Allow me to introduce you shortly to ICT Group. ICT Group is a leading European industrial technology solutions provider, founded more than 40 years ago in the Netherlands. The world around us is changing fast. Digital transformation significantly impacts the way we live and do business. It offers huge potential to make the world smarter while contributing to a more sustainable future. ICT Group is committed to playing its part in making the world a little smarter every day. It's our ambition to help our customers to make their business processes more efficient, flexible, simple, safe, and as a result, more sustainable. The feedback that we receive from our customers reflects that we are able to do that because we combine our domain expertise with our technological expertise. We are proud of what we achieved. With a track record spanning more than 40 years, ICT Group has both extensive multiple domain expertise and in-depth industry knowledge. Integrating these strengths into compelling technological solutions puts us in a unique position. We focus on 4 areas: R&D engineering, industrial automation, infra and mobility, and healthcare. And within industrial automation, we focus on the logistics market, like ports and warehouses. With our solutions and managed services, we serve our customers. And furthermore, ICT Group delivers its own software products, including a cloud-based platform for IoT, digital transformation, and artificial intelligence, and proprietary software for instance, mobility as a service. After this introduction, it's now time to direct you to the speaker of this webinar, Karsten Pereboom. I told you already, Karsten is one of our business consultants with the domain knowledge and expertise in port logistics, and in particular container terminals. He has worked, for instance, for Portbase and Hutchison Ports ECT Rotterdam. During the webinar, Karsten will present our vision on container terminals and what we think is required to become a part of the smart port. Karsten, the floor is yours.
Bart, thank you for your introduction. Let's set the stage. Over the years, ports and terminals have evolved through several basic models of operation. In the early days of terminal operations, loading and unloading of vessels was hard work. The Terminal 1.0 was typically management by heroes. Individual pieces of machinery, such as yard cranes, were adopted as a first step into mechanization. Workers drove their machines, controllers linked individual process steps and directed yard operations. The next step into automation needed a more process-oriented approach. With the Terminal 2.0, management by process, ports govern the steps of these processes. Using a terminal operation system, operators made most decisions from the central room. Terminal 3.0, management by exception, is a progression from Terminal 2.0, automated equipment into digitalization. Algorithms were used to optimize processes. Automated equipment could handle most of the work. Human operators now only had to handle the exceptional cases. But Terminal 3.0 isn't the end of the story. The terminal of the future contains even more automated systems. With algorithms getting smarter, Real-time berth planning is waiting just around the corner. Autonomous vessels are in the early stages of testing. With all the information flowing through the individual systems, overall monitoring becomes more difficult. The challenge will be to let the systems work together efficiently. And for that to happen, the closed automation silos need to open up. Revolutionary as the closed automation silos were in their days, they limit your business today. A new approach is needed if you want to stay in control and get ahead of the curve. Changing closed automation silos into open orchestrated systems is key. In the model of the future, Terminal 4.0, from manage to orchestrate, ports will enlarge their role by orchestrating physical and information flows inside and outside terminals to enhance the terminal ecosystem's broader and system-wide efficiency. The cornerstone of Terminal 4.0 is real-time information steering the whole process chain. In order to do so, systems need to be able to interact with each other. This challenge is reflected in the following quote by Jim Fletcher, IBM's CTO. The biggest problem to industrial IoT is legacy equipment in the field, non-standardized protocols, and the fact that there is no horizontal integration platform that brings all of this together, especially not something that can do bidirectional communication back into the edge and have these subsystems to interoperate. Breaking change to optimize the chain. The unified platform serves as a visual example of how technology is being integrated into the industry. The predominant trend was that automation solutions do not stop at the field or control level. They also include functionality at supervisory and planning level, such as dedicated management and monitoring tooling. This resulted in solutions living in their own silos with no or limited possibility for interaction. These systems in general only work well with equipment from that single vendor, and that comes with the price of a vendor lock-in. It requires a repetitive effort, for instance, when it comes to DOS integration. The closed automation silos complicate the collection of data. That makes it next to impossible for cross-system tasks, such as coordination and planning, to reach their full potential. What is lacking is a conductor leading the orchestra of automated systems. Our vision is reflected in our holistic solution, the Container Terminal Unified Platform. By integrating those solutions, it breaks the chains of vendor-specific solutions. We deliver a unified platform for vendor-independent planning, equipment control, and collection of data. Equipment from different vendors fulfilling the same role, example AGVs, can be put to work together. Data collected from different subsystems can be combined in real time. This enables complete insight in the operational performance of the terminal as a whole. Compare this to the old situation, where each independent solution could only be monitored effectively in isolation. Equipment vendors remain in control of what they do best, build best-in-class automated equipment. You, however, remain in control of what happens on your terminal. The unified platform serves as middleware and is associated with consistent terminology with translation at the edges for the vendor-specific languages, which consist in the use of information and operation models. The unified model serves as the basis for information exchange between the connected subsystems. We are convinced that smart terminals are the way forward and will make the difference in the end between extinction and survival. With the unified platform, we are able to contribute to this Terminal 4.0 and providing means to get ahead of the curve. It comes with architectural principles as availability, scalability, independence, and security. The architecture is highly available due to the usage of multiple node infrastructure without single points of failure. Also, application of load balancing ensures load is spread evenly across the available nodes. It's very scalable and can be hosted on-premise as well as in the cloud. we abstract away from specific equipment communication protocols and data formats. We ensure open and independent middleware service by using industry standards and unified data formats. Security is implemented by design. Nobody wants to be next week's headliner, like the Colonial Oil pipeline was the other week. Note also that our solution is fully ISO 95 compliant. Traditionally, ISO 95 has been implemented in a 5-layer system network architecture. It implies that each level only communicates through the adjacent levels. This does limit your flexibility though. With the unified platform, we also incorporate the ideas of the reference architecture Model Industry 4.0 into the standard. We decouple ISO 95 from the traditional layered network hardware model. Instead, we take a holistic view to the automated equipment and processes on the terminal. By opening up these closed automation silos, individual systems and equipment can work together and communicate directly with each other, increasing the overall efficiency. The use case at ECT. The unified platform has grown out of 30 years of experience at one of Europe's foremost container terminals located in the harbour of Rotterdam. At one of Europe's oldest automated container terminals, ICT has developed smart IT solutions for their planning and order management, involving all modality and cargo planning as equipment control. These systems, which lie at the heart of terminal operations, are supported by various web and mobile applications. The potential offered by a unified system can be seen especially well in ECT's Dynacore. It's responsible for planning of various container movements on all available equipment. Other modules communicate with Dynacore. This has enabled ECT to develop several new functionalities together with ICT, such as planning, stacking algorithms, dual cycling, AVG cycle speed, up to a digital twin, which we will revisit later on. The use case at PSA. One of the places where ICT has put this vision into place is at PSA Antwerp. It's part of a larger effort aiming to transform segregated and individually and manually operated equipment into a semi-automated, cohesive environment. By breaking the chains and moving away from vendor-specific solutions, PSA is able to make breaking changes to its terminals. ECT has developed a middleware solution to connect the equipment on the terminal, called Connector. Connector supports many types of equipment. It has been deployed on terminals working with straddle carriers, as well as terminals using stacking cranes and prime movers. Connector combines both manual and automated equipment on a single terminal. Connector is also a great example of how the unified platform breaks the chains of vendor lock-in. Different PSA terminals use OCR solutions from different vendors. The vendors provide specific hardware, such as cameras, whereas Connector takes care of integrating the hardware with other systems. In this way, Connector provides a seamless environment on any terminal. User-facing applications, such as Web Portal for handling OCR exceptions, showing assignments in manned equipment, or remote control of automated stacking cranes, are all part of Connector. The look and feel of these applications is the same, regardless of which vendor provides the actual equipment. Operators do not need additional training to work with the new equipment, for instance. Connector abstracts away from such details. It makes it easier to combine equipment from different vendors. Ultimately, it leverages your lifecycle and contract management by the freedom of choice of adapting new vendors and moving away from others. Using these automation systems, container terminals slowly change from an environment where people are assisted by technology to a technology-driven environment. For instance, we create smarter ATVs by making them actually dumper individually. As a result, of shifting the intelligence to the brains of the unified platform. All joy and bliss? Or is there also a downside after all? Let's have a closer look. Before, we had an extensive staff of operational people on the terminal. Besides their main task of their job description, they also intervened as soon as they noticed things were going wrong. Before, people noticed flaws in the process and thought of ways of improvement by trial and error. In retrospective, these experiences were used as input for improvements of processes, IT and OT. Now, what is to be done when you've only automated systems and very limited eyes on your terminal? Digital intelligence, breaking change. Well, all information flows through the unified platform. This way of working sets up the ideal conditions for gathering data and gaining in-depth insights into everything that happens on your terminal. Continuous improvement. We have developed a model that digitally transforms any company in 4 steps. The unified platform embodies the first step. It connects equipment as well as other subsystems and enables the gathering of data. Next, the collected data is transformed into information. An important aspect of this transformation is combining data from different systems. With the collected information, it becomes possible to make informed decisions and take control of the processes on the terminal. By continuously repeating this effort, it enables the process of continuous change and improvement. For one of our customers, we have succeeded to reduce the average number of unplanned stops by AGVs, over 75%. In monetary terms, this improved AGV traffic flow has resulted in annual savings over 250 grand in fuel costs and K crane man hours. With the unified platform, the first step comes almost naturally. It connects different types of equipment and uses a unified data model. This ensures that gaining insights happens almost automatically. In the current ecosystem, it's still a challenge to add new systems. Driving performance is hard, as creating information from different types of equipment and different brands is currently complicated by the fact that there is no common language. Each equipment vendor has complete freedom in which information is provided and how the information is formatted. Different vendors rarely provide the same information in the same way. But hope is on the horizon. In today's world, even when you're not thinking of an automated terminal, the terminal operators expect that they will be able to exchange information with their fleet of equipment. As in our day-to-day life and in many other industries, the concept of Internet of Things, or Industry 4.0, is already here. To be able to connect the equipment, we need to agree that we talk the same language and use the same words and definitions. This challenge has been taken up by industry stakeholders with the foundation of the TIC 4.0 Association. TIC 4.0 regroups container terminal operators as their suppliers of terminal equipment and solutions to properly define unique physical elements. It does so by a common vocabulary, a grammar, and the associated protocols for digital transformation. In other words, by agreeing on a common language for the container industry. This common language will not only apply to machines, but also to all of the people that are going to work with this virtualization. ICT has picked up the gauntlet and is developing the initial pilots based on the current definitions proposal together with PSA. The first project is a standardized interface between PSA straddle carriers and their back-end systems. Some more use cases. There are many ways such data can be put to use. Think of a simple case like the wear and tear of tires. This can be monitored by tracking the distance driven. Combine this simple piece of data with GPS information and it becomes possible to take the number of times the equipment has made left or right turns. These events could lead to faster wearing of tires on a specific side. And by monitoring the tire pressures, the pressure can be kept within certain boundaries to improve fuel consumption. Taking this information into account, and you can optimize your maintenance and cost of operations. The unified platform also enables new ways of providing support. Service 4.0 focuses on providing higher productivity and applies innovative techniques. Where traditional services would help to resolve a problem once it has occurred, with Service 4.0, the data flowing through the unified platform can be used to prevent problems before they occur. With adaptive learning data, such as tire pressures, can be used to train algorithms to automatically monitor your equipment. Predictive maintenance helps to avoid disruptions and outages. While the concept isn't new in itself, technologies such as the unified platform enable their broader adoption though. Knowledge management, including ways to create, harvest and share knowledge, is the essence of Service 4.0 framework. This includes extracting insights out of an unstructured data from failure situations, such as videos, images, or available technical documentation. And there are sophisticated methods for interacting and communicating with service partners. Artificial intelligence and chatbots, with natural language understanding, machine learning, virtual reality, and also augmented reality are applied. Digitalization allows for product instrumentation, so actions can be performed remotely. Actions may be divided into diagnosis and repair tasks. From a technology standpoint, multiple items are needed. Sensors, edge computing devices, analytical capabilities, 5G, cloud, and IoT platforms, to name a few. However, technology services go beyond supporting a product. As many of us know, the service is the product. Transparent access to services is paramount. To achieve this, service companies often use analytics and visualization technologies to provide reports and dashboards, as may add simulations to offer recommendations for next best actions. Knowledge management is supported by real-time dashboards based on the information flowing through the unified platform. These dashboards provide valuable insights into the processes on the terminal and the automated systems themselves. Automated monitoring and alerting is available as assistance to service engineers. The tooling allows engineers to drill down into a problem, find the actual root cause, and solve that instead of fixing the symptoms. Predictive maintenance by itself is an excellent example of how different information sources can be combined to get useful information. Data from different sources, such as failure and maintenance histories, actual machine conditions, and container flows can be used to identify warning signs of potential problems. Derived information can predict when equipment needs maintenance and preempt the service of equipment before the problems actually occur. Combined and aggregated data from all systems in your dashboards can be extremely useful to monitor the equipment in real time. By setting the proper alarms, problems can be prevented before they occur. Although algorithms can be very powerful, they might lack the intrinsic human ability to recognize patterns in typical occasions. These human strengths can be leveraged by showing information in ways humans can naturally relate to. One way is plotting information on the map of the terminal. This picture shows the hotspot for certain types of congestions and their associated errors. An experienced human service engineer can use such a visualization to deduce the possible causes, and that is the first step towards the remedy. The next step is to create a virtual counterpart of the container terminal, a digital twin. The digital twin provides real-time insights on all processes of a terminal. It is fed by live data collected from the various systems running. The data are shown in a concise and recognizable way in a 3D digital representation of the terminal. The digital twin can be used to see what's going on your terminal. Next to that, information recordings can be used to test optimizations or new software, thus minimizing the risk, and it limits the impact on your operations. On top of that, iterations go faster. Improvements can be released more often, thus leveraging continuous improvement. A digital twin can be also used in virtual and augmented reality applications. Virtual reality can be used to supplement training activities. Augmented reality can provide real-time information to service engineers working outside on your terminal. The architecture of the digital twin is based on the latest insights. It uses a microservice architecture to allow ease of module swapping. This is important as it enables to simulate different kinds of terminals with different kinds of characteristics. It also enables testing different algorithms and their impact on the various terminal processes. By speeding up the simulation rate, events of an entire day can be compressed to a fraction of the time. This makes it possible to test multiple scenarios in one day, where this would have taken multiple days without a digital twin. Key performance indicators values and the impact on them can be calculated dynamically. Short iteration cycles means that multiple variants of an algorithm can be checked to see the differences and finding the ultimate one. This makes it possible to keep multiple possibilities open just before making the final decision. Finally, I want to conclude this presentation with a demo of our digital twin. It also shows a simple application of integrating data from the terminal in this 3D visualization. A vendor-independent solution allows terminals to choose from best-of-breed offerings from different vendors for each task on the terminal. The unified platform is an indispensable link in your terminal automation. It is the central location for collecting information and forms the gateway for optimizing automated processes. By breaking free of the chains imposed by using vendor-specific systems, you open up the way for breaking changes on your terminal. You will get the best out of your investments by continuously improving the entire process chain.
Okay, thank you, Karsten, for this presentation. Just to wrap up, what we told is that we bring people, technology, and ideas together by linking our knowledge of your market to innovative integrated IT solutions for your company. Product, project. And our challenge is to make the world a bit smarter together with you. We hope that you remember that a unified platform, like we presented, is the key to be able to collect data and the way to a smart terminal. In the webinar, we have presented you our involvement in standardization of interfaces by the TIC 4.0. And in addition, we have shown some practices like the digital twin. Allow me to address you to another webinar that ICT Groups organizes on the 8th of June. And the title is Digital Twins for High Tech and Manufacturing. You can read our cases on our website and to find how we create added values for our customers. However, I hope that it is possible to visit us also at the TOC Europe 2021 in September from the 7th to 9th in at Ahoy, Rotterdam. Having physical contact is always better than having contact via digital channel like this webinar. And in addition, we will contact you within a few weeks after this webinar just to hear what we can improve and perhaps how we can support you on your road to a digital or even a smart terminal. Thank you very much for your presence.